lines. Now I picked these out for a reason. They're all between 100 and 600 responses, which is the most hot area for finding regional distributions. And so we have the most chance of doing something. So let's run the program for finding a regional distribution. Okay. It's working. Our first matrix, that's a 10 by 10 matrix, and 2 patterns has come up, and now it's just processed 6 files of 1,162 rows in just a few seconds, and it's made me the same 100 data points, but in a 2-color pattern, a 3-color pattern, a 4-color pattern, and a 5-color pattern. This is a U matrix which gives a statistic about how related the dots are, how related the nodes are, but I won't go into that now. So let's get out of that, come over here, come to the interface, go to the results, and let's look at the 3-pattern solution. Here are our dots again. Now, what we're seeing is that in our set of nodes, the blue ones are the first one, the green ones are the second one, the red ones are the third one, and it goes through the same sequence of colors each time. The display down here at the bottom tells you whether any or all of the 6 words that we submitted have been selected. The first number is if it wasn't selected. The second number is if the first, second number, if it's close to 1, says that the word's been selected. So the blue pattern selects quarter of most frequently. This is missing data. There wasn't any missing data. Now, 80% of the speakers in the second node, or in the blue pattern, did not have the second one pretty day. 20% did. So you see how this works. We just for rough calculation, we can say that if we can do it by quartile and say that 75% occurs in the second number here, that something has been selected, between 50% and 75% that there's a trend. If it's between 25% and 50%, then there's a trend against, and it has not been selected. There's a very low average frequency. But that's basically how you read the chart. Now, one thing that we can do here is select some features. Here, let's select this one. With our tool. Now we'll display a map. Of course, it doesn't have a map yet because it's a GIS in layers. So let's, oops, too far. Let's add a coastal shape and response. And what we see here is that the yellow ones, you can see them more clearly if I deselect that layer, that's where the people were in the node that was selected. So what we can do is come back here. In this instance of the program, it's difficult to select all of the colored ones, but let's just take a big block of red ones here. Oops. So and we can also make a map of where most of the red ones are. Now this, of course, is the one that's selected pretty day, which should be southern. It's not. We didn't get all the red ones in there, but it's not going to be southern no matter what we do to it. So what you see is that selection of a particular feature doesn't necessarily matter. Now I'd like to just show you quickly the results of, we'll just get rid of all this, Excel file. Here's quarter of pretty day dog iron shell And for the two patterns, you can see that Pretty Day was selected in the second pattern when we asked for 2, but look at all the M's. Most things were not selected. What you see here is a pattern for what was selected to create the patterns by the neural network algorithm. You'll see that here's another 6, and that curtains was the thing that was selected. Of course, that's not Southern, that's a general feature. And down here in another 6, these are all from the same items, but just different vocabulary variants. Quarter 2 is often selected. Nice day, andirons, and whitewood, and mantelpiece are the more Southern ones. So you can see that the patterns of selection for the averages for the colors in those patterns may not look like what you would expect to find, that it's going to be yes, yes, yes on some words and no, no on the other two. It just doesn't work that way. It's much more complicated than that. Now, in fact, the process doesn't really work when you only do 6 words at a time. And the reason is that there's too little data to be submitted to the program. There are 729 possible nodes, 3 to the 6th. My math is right there, 729. If you submit 6, but let's say we submitted 18, all the ones that were on there, then we have 387 million possible nodes. And we would be selecting the best 100, and so that's what I did. And if you do that, you get a picture like this one. The pattern that looks the same as before, but there are not so many empty nodes anymore. If we look at a map of the red region, then what we see is that the red region that's probably the south is pretty southern this time, so it seems to be working much better, but we have all of this nasty stuff up in the north that we don't want. Well, let's make some more patterns. If we looked at the map for, if we asked it for 5 patterns and we looked at the most southern one, we can see that we get rid of some of that. That some of them have been assigned to other patterns. If we look at the map for 6, we see that we've gotten rid of most of them. So we have a pretty nice south, don't you think? Of course, there are 5 other patterns that were found. And what I'd like to do just to end is to show you quickly the maps when you ask for 9 patterns. And let's start with the blue one. And this is the blue dots on the, if you ask the same matrix of 100 nodes for 9 patterns. Is that Southern? Well, sort of. Midland and Southern. Let's look at the green one, the second pattern. That one's North and North Midland, pretty clearly. I'm using Korat's terms here, obviously. That if we now look at the red one, the third one, then that one is West Midland, if anything. But these don't exactly correspond to Korat, though, do they? If we look at the light blue ones, the next one, well, that's Midland and Southern. If we look at the purple one, that's Southern. But has anyone ever proposed a South that looks like that? What does it mean to have a pattern that looks like those yellow dots? Here's our yellow pattern, the next one. Now this one has the Charleston region, the Virginia Heart, New York City, and a bunch upstate New York. So what are we going to make of that one? And a dark blue pattern. This looks like a South Midland, but it's going up into New York State. So what do we do with that? Here's our brown one. This is the most southern of our patterns. And our last one is dark green. That one is West Midland, West Virginia. Okay. Now, you've seen them fairly quickly, but you've seen how the program works. Now, poaching on a minute of my time, I'll just suggest that this program has not helped us to find the South. We found about 6 Souths, each of them defensible in core ops terms. And so the mathematics here are really promising, much better than I thought a year ago when I wrote a paper that said that it didn't work because I wasn't giving it enough data. But I think this is instructive because any discovery technique for mathematics that we apply like this is going to show us a picture. And it may make us happy, this picture, but we don't know what it means. And so what I would suggest on the basis of this and other quantitative methods that I've applied is that the key to life in quantitative processing and discovery techniques is to create careful experiments so that you have some chance of being able to interpret your results. Thanks.